Hi, below we will explain the recent simplest below the following example. Problem of maximization. Instead of this algorithm, the maximization problem involving their variables for constraints all constraints are in the form of a list there are equal to start from of the problem. Of course, will all select variables to the problem, so this is problem that involves x1, x2, x3, and x4, or basic variables initial state basic flex solution are going to be those variables. The state of the simplest variable are basically the same as they there as the simplest method except that in this case you don't have a table and you are only deal with the matrix. So let's start. The matrix is then defined. The elements of the matrix P1, P2, and P3 are defined. The right have variable. The rows are defined at the cost or profit vector has been defined. Vector C has been defined based on the hidden information in the problem. Now we are going to look at the calculation related to this specific basis. In this case, our basis includes S1, S2, S3, and S4. The matrix B is formed from the coefficients of these variables, the basic table solution. We have the basic variables S1, S2, S3, and S4. B is formed from the original problem. Of course, S1, S2, S3, and S4 are related to the identity matrix, so we'll have the identity matrix decided. Here we are going to have the corresponding objective for function values of these bases, with of course there are none of the in the objective function there are all zeros, and we will do the calculation. We'll find the B inverse. We will fill the CBB inverse and minus C. We will find CBB inverse. These two variables are the optimal condition. The identity where the problem is optimal or not. In this case, I have negative 2, negative 5, negative 3, and 0, 0, 0, with B having the negative variables and they having a maximization problem in the index to vector. I call the problem is not optimal. su Python, the most negative variable is here, which of course this variable is related to this is x1, x2, and x3 columns.
This is x1, x2, and x3 columns. This is x2, therefore x2 is going to be my entering variable. To identify what my leaving variable is, I have to calculate the right-hand side values, that's inverse b. When I do the multiplication, I get these values from that multiplication. To identify the leaving variable, I have to find the mean radio. And the mean radio is the radio of these elements over the pivot columns. We know that in tabular format, in this case, that value is calculated by the inverse multiplied by P2 because x2 is the entering variable, the inverse P2 is calculated and the values are identified. We are going to find the radius 16 over 412 over 1. Now notice that we are not doing this radio because it's a negative number and we now animate that is negative or 0. We are not going to do the calculation and the last one is 4 over 2. So these are the radius for use and the mean radio in here is 2, which corresponds to this value, a last one in here, and that is corresponding to S4. Therefore, x2 is going to enter the basis replacing is 4. At this time, really, we don't need to do the C calculation, but that's how you calculate C value. The value, of course, is 0. In this case, because CB is 0, now at this point we have two options. One, we can do is processing. In this case, a P1, P2, P3, B, and C are the same matrices that I had before. However, now my basic variable set my basics change and x2 enters and replaced is 4. In this case, I will change that and my xb will be represented and is 1, is 2, is 3, and x, the b accordingly need to be changed. So, on the last column, which was the column of is, for now, I will have a column associated with x2. Similarly, the CB needs to change the value of as for in the objective functions was 0. The coefficient of is, for now the coefficient is relative to x2, which was 5. I will replace that and then I do the basic calculations. Required as I get to this point and I will look at my two vectors that are representing the optimal conditions for my end. Notice that there I still have negative number in here and in here.
Everything else positive and this one is much negative. It's corresponding to x1, so x1 will enter the basis to identify which one is the leaving variable. I have to do additional calculation. I have to write side b multiplying b inverse time level b. The values are calculated here, and because x1 is the because x1 was the leaving variable in this case, again I'm going to calculate to inverse p1 and the values are here again. Notice there is a negative value. So I'm not going to do calculation for finding the relation for this element. However, I will calculate the mean relation for 8 over 5 10 over 8 halves, 17 over 7 halves, and those are the values in here. 8, 5 happen to be smaller on correction to as 1, so x1 is going to leave the basis and x1 is going to replace that as I said, because we are not at the optional solution. We don't need to do calculation for C, but this not formulate and the calculation exit in here as well. So note we are going to go to the worksheet 3, and in this case same worksheet and just copy and just modify and change it so it's not a difficult task to do so. A P1, P2, P3, B and C. The new basis is going to be x1, s2, s3 and x2. According, it will shade my v-shots that x1 columns is now replacing the x1 columns that I have before. Similarly, the first element of CV is going to change to represent the coefficient of x1 in the objective function. I will do the calculation and I will end up again with the two vectors that are representing the optional condition. Again, I will note that there is a negative value in here. Therefore, it is corresponding variable to this on is the entire variable. And that's over again, that's x1, x2, x3, and that's the only negative number in this to set. So x3 is going to enter and to identify the living variable again, I have to do the calculation for the inverse for B inverse B and for B inverse B3. This time is a negative number.
I will calculate ratios for these corresponding rows. In this case, the main ratio happened to be 7 over 6, which is corresponding to S2. So based on what we have said, x3 is going to enter the basis, replacing S2 again. As I'm mounting it, we don't need to do any calculation for the C, but if we can use the formula to do the calculation now, we're going to go to the next gain, the sum steps, initial steps. However, now I have a new basis. So, or for me new basis, which is x1, x3, x3 and x2, I will accordingly change the B matrix to represent x1 coefficient of P1, x3 coefficient, that's P3, x3, that's the coefficient of S3 in the original problem, and it's cut, and that is P2 values again. It will change the CV accordingly. A3, which was the coefficient of x3 in the objective function of the original problem, is replaced here, so that's my new CV. I will do again the calculation, and as it get this point, I notice that there is the negative values in here, so this solution is the optimal solution. I will calculate your right hand side values and will calculate the C value, and those are the optimal solution that I will report for this problem. The optimal solution is writing in here.